So we're Algebra 2, Module 6, Lesson 1, page 271, adding and subtracting polynomials. So our essential question is, how do you add or subtract two polynomials, and what type of expression is the result? So that's what they want to know, is when you add or subtract them, what happens? What do you end up with? That is the essential question that they're asking. So let's have our explore. Identifying and analyzing monomials. So move up. So kind of way to think about it, remember mono means one on one. And mono means one. And that's what it originates from. Okay, so monomials and polynomials. A polynomial function of degree n has the standard form of px equals a n x n plus etc. 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 Okay? And what you have is where your a coefficients are real numbers. So in other words, like 2, 3, 4, right? As long as an an does not equal 0. So when we have our given expression, this is called a polynomial. And each term of the polynomial is called a monomial. So remember, a term is a group of numbers and variables that are separated by addition and subtraction. So whenever they're a group of a whole number and a variable, and it doesn't even have to always be a whole number, just a real number, and a variable, and then you have a plus or minus another number and a variable, then that's the separation of terms. And each one of those is a monomial because it's one group. Okay? So a monomial is the product of a number and one or more variables with a whole number exponents. Okay, so our exponents have to be whole numbers. A polynomial is a monomial or the sum of monomials, groups of them. The degree of a monomial is the sum or the addition of the exponents of the variables. Right? And we'll get into that more in a little bit. The degree of a polynomial is the degree of the monomial term with the greatest degree. The leading coefficient of a polynomial is the coefficient of the term with the greatest degree. Okay, so we got a couple different things going on here. You have your degree of your monomial, okay, which happens when you add up all of the exponents of the variables. So as with any word problems, you kind of read it once and then you go back and read it again. So when you add up all the exponents of the variables, that is when you get the degree of that monomial. And the degree of a polynomial, which, if you remember, is a group of monomials, is when you add up all of the monomial's degrees, and whichever one is the greatest out of all the ones that are together, that is the degree of the polynomial. Okay, so it's kind of like championships. Each one you add up, and if you have a group of them, whoever has the largest one is the degree of the polynomial. The leading coefficient is the coefficient of the term with the greatest degree. Okay? So let's see this in action. So identify the monomials. So we have here's one group, and here is another group, and here is a group, and here's a group. So they want you to find the monomials. So these ones are monomials because if you notice, this one here doesn't have anything that's added to. This does. This is 1, 2, 3, 4 terms in it. Here, nothing being added to it, nothing being added to it. And here we just have an exponent of 0. So that's why the variable just has an exponent of 0, but it still counts. And our non-monomial is the one that was added together. So identify the degree. Move up. Of each monomial. So remember it said the degree of the monomial is when you add up the exponents. So if we add up our exponents, and to note here, what is the exponent of b? So you can actually pencil that in and put that down, because that still counts. And well, what is my exponent here? What did I say was our exponent? So go ahead and fill that one in. And let's check your answers. So the degree should have gone 3, 15 because it's 12 plus 1 plus 2, 15, and 0. Alright, so what is our next bit of information? It says identify the terms of the polynomial. So what are the individual terms? And you can separate these just kind of like they have up here by parentheses. So I'll give you a hint. There's 4 terms. So go ahead and write them down if you need to. Pause the video. Okay, and otherwise, hopefully you paused it and wrote it down. Those are 4 terms. Now note, that one has the sign. You take the sign with it. Okay. So identify the coefficients. So what were coefficients? You go back up to the beginning or in our notes. Coefficients are the numbers in front. They're the whole numbers, the the real numbers. So what is the invisible number that is here? What is my real number here, here, and here? Go ahead and pause the video if you need to. Otherwise, write it down and show the answers. Remember, you want to be able to practice on your own because that also builds confidence in your skill set versus just copying. So those are our coefficients. So when we go to adding, subtracting, multiplying, or dividing, that's what we're going to be working with. If we add our coefficients, we'd be adding our 5 or a 10 or a 3 or a 1. Subtracting, the same thing. Multiplying, the same thing. Dividing. So when they talk about coefficients, that's what you applied the operation to. Okay. So identify the degree. So degree of each term. So you'd add the exponents together of each term. Pause the video and complete that now. Okay, our answers would be, and that is our exponents. Now if this was x to the third, something like that here, then this would be a degree of 5. Because again, kind of like degree of monomials, degree of terms, basically the same thing. Yep. So write the polynomial in standard form. So the only thing that means is to rewrite it in decreasing exponents. So pick your largest, your next, and your last is standard form. So go ahead and pause the video and you can write it in standard form that way. And check your answers. There we go. So last but not least, what is the leading coefficient of the polynomial? And so leading coefficient was the coefficient of your largest degree. So look back at your, once you put it in standard form though, that's the biggie. then you can identify that, which was -5. Right, so let's go to the other page. How can you find the degree of a polynomial with multiple variables in each term? So again, this is like x plus, or x to the second, y to the third, plus x to the fourth, y to the fifth, plus etc., etc. So what would you do to find the degree of a polynomial that has multiple variables in each term? Go ahead and look back over your notes and think about it and write down what you believe is the answer. Pause the video. Again, this is about you interacting with the notes, not about copying the answer. Okay, so let's just check our concept. So you can find the degree of each term by adding the exponents of each variable. The degree of the polynomial is the degree of the term with the highest degree. So that just means you'd add the exponents of each variable together is what you'd do, and then compare them. All right. Up next is explain 1, adding polynomials. I hope this helped.